As Steve says, my name's Neil Kettle, and I'm here to give you a quick rundown of a small little program, or maybe not actually that small, called Trusteer Rapport. You may or may not have seen this, depending on which bank you actually use. The information that I'll give you in here is basically just only about one aspect of Trusteer Rapport's protections, so if, as it happens, namely to do with keyloggers, so we'll start. Okay. Well, first of all, I'll give you a disclaimer. Obviously, I don't want you using this maliciously if any of you happen to be Russians. I'll then go into a background with the marketing, which is, suffice to say, completely pervasive. Trusteer are brilliant at marketing. Pity they're not brilliant at anything else, but that's another story. Awards. Trusteer have a habit of being awarded just about everything from about everybody. The customers should be separated from the users. The users is you. You're the poor unfortunate that has to run this and trifle with blue screens and all sorts of dodgy stuff, because Trusteer aren't exactly the most subtle of kernel programmers. The customers are, of course, financial institutions, but we'll come to them later. We'll then use a simple scientific approach to taking Trusteer apart, something which supposedly had been done before, but I'll show pretty much hasn't. We'll critically review other reports that are out there. There are several. We'll then make a hypothesis as to the design of Trusteer, which is absolutely obvious to anyone that looks, even considers how it might work. We'll then use experimental evaluation with a few demos and then we'll just conclude. So about me. So I'm a reverse engineer, a bug hunter, an exploit coder. Actually, other people have many other names for me. Many of them I can't actually repeat. I personally wouldn't want to. Anyway, so this talk will break from previous reviews of Trusteer Rapport. As I said, there are at least 3 that I can count. Whereas previously, and more importantly, in the case of ongoing tests, they've been vendor, or in the case of ongoing tests, well, actually, I don't actually know there's an ongoing test. It's just word on the street, or, well, to us, word in the channel, that they are government coordinated with the banks. So there is a popular UK security company looking at this with supposedly with CESG, so never fear, the experts are on the job. And we will show how, with respect to just one aspect of its protection, that is the keyloggers, well, it's slightly disingenuous in that it doesn't work. You require precisely 0 skill to do or to use any of this. Anybody that could simply just read even the smallest amount of assembler would instantly be able to find a way to subvert Trusteer Rapport on both Mac OS X and Windows. However, while I will give you all the tools you'll need and actually demo it on OS X, I won't do the same for Windows, because obviously it's far more useful, and you never know, there could be Russians or Chinese in the room that actually want to use it. But I will just tell you how you can do it anyway, so you can just implement it yourselves. Okay, so disclaimer. First of all, none of this was fuzzed for obvious reasons. And second of all, this is for educational purposes only, unless you actually write keyloggers for a living. The results contained in this talk were entirely reverse engineered, so of course I can't promise that anything works other than the fact that I can show you it working. If you want the code, you can have it for OS X. Like I say, Windows, you'll have to, well, actually you'll have to copy and paste from the talk, which is quite difficult, and then you'll have to use a compiler, which for some is even harder. So moving on, okay, we'll touch on the background of Trusteer. Trusteer is a company founded in 2006, and from the map that's on my office wall, it's in a town called Jaffa, Palestine, but they say Tel Aviv, Israel. It's backed by a firm of US venture partners. Trusteer's principal product, Rapport, according to them, helps online banks, brokerages, and retailers secure the consumer desktop from financial malware attacks and fraudulent websites. So we'll put that one to the test. Trusteer has an extremely active marketing department, to the likes of which I've never seen previous. These are just a few of the select quotes. First of all, Trusteer, according to themselves, protects login credentials and transactions from desktop to website, even if the computer is infected with malware. It blocks Zeus, Torpig, Silent Banker, and other man-in-the-browser attacks. Its proprietary browser lockdown technology simply prevents unauthorized access to information. Okay, whether these attempts were generated by new or known Trojan variants. Okay, and apparently it blocks keyloggers and screen grabbing. Unfortunately, the screen grabbing stuff is actually a lie because that doesn't actually exist on OS X. Evidently, they couldn't even be bothered to reverse engineer the DVD player implemented by Apple, because if anybody has ever used an Apple Mac, you'll know that if you're actually watching the DVD using Apple DVD player, you can't take a screenshot. So they couldn't even be bothered to figure out how Apple did it. That's another story which I won't touch on. Well, awards have been, suffice to say, lavished upon Trusteer. SC magazine were the first out of the blocks in the race to see who could lavish the most love and affection upon Trusteer. In 2009, they named them Innovator of the Year. There's actually an interesting quote here for anyone that actually has anything to do with malware analysis. It's from a Peter Stevenson, who's a technology editor of SC magazine, who wished to qualify his remarks, giving them the Innovator of the Year. He says, if you do all these things that Trusteer does, because that's self-evident, because they say they do, so obviously they do, you don't need to worry about identifying and responding to specific pieces of malware, and zero-day exploits become far less common. Right, so if you happen to work for McAfee, you can just leave and go and jump off a building because you're no longer needed. Frost & Sullivan were the second out of the blocks. They said, well, they gave them the Fraud Prevention Product Innovation of the Year in the same year. If you actually if any of you are actually budding propagandists, you should probably read a Frost & Sullivan report and actually read the research methodology part. I mean, it's almost as bad as Gartner and the Magic Quadrant. That's actually point 2. If you really do want to be a good propagandist, never use the term magic when referring to research, unless you happen to be the Pope or you're in the Vatican or something like that. Of course, SC Magazine, they kicked off again in 2010. Best Secure Transaction Solution this time. Softpedia, well, they got in on the act in 2011 and declared it 100% clean. That is free of viruses and malware. Of course, Softpedia, I won't be surprised if they give Sony's software the 100% clean. It's 100% clean of malware written by bad guys, not yourselves. So, there you go. My personal favourite is the Red Herring Award, which was either named by a complete moron or a genius subversive, because a red herring, I don't know if you know the dictionary definition, is something used to divert attention from the real matter, issue, or object. Whoever came up with that name, yeah, a man after my own heart. Anyway, moving on, the customers. Well, it's hardly surprising, given the aims of Trusteer Rapport, who the principal customers are. Remember, users, very different from customers. The customers are financial organisations, PayPal or eBay. I'll give you 2 examples that aren't on this list. In the UK, you have the following banks, at least the following banks are pushing this. You can see from here there are 12 banks. That's slightly disingenuous because it's possible to group them together, as I've done here. The banks at the bottom are the too BTF groups, so that's the too big to fail groups. The ones in the middle are somebody else's problem if they crash, and Metro Bank is a small bank, if you've ever heard of Metro Bank. They're expanding in London, presumably because at the moment they are still small enough to fail, but not for long. Moving on to the users. Well, the users is you, obviously. They have a slightly different outlook, and this is ubiquitous across the board. Some guy here, he says that you should uninstall Trusteer Rapport and never touch such garbage again. He then goes on to say, follow the vendor's instructions, and I can't tell you how, which is self-evident, really, considering he's posted on an Apple blog. Therefore, probably doesn't know how to do much. Another guy, he says that NatWest scared him into using it, and it virtually killed his PC. Which is kind of standard. If you Google Trusteer Rapport and blue screen of death, you get hundreds of thousands of hits. Trusteer aren't the best of kernel programmers. So why bother? Well, firstly, it's a very interesting target, given the customer base. Remember, that's the banks. Secondly, security products which are backed with such rapturous applause and completely implausible claims provide virtually an open and shut case against marketing. Give you a quote from John Viega, I hope I said his name correctly, who's a director of an antivirus solution development company, who actually claimed that Trusteer Rapport was little more than snake oil, but yet lacked the proof. He states that the company's marketing department can always find someone happy with the product, so therefore it turns into a battle of credibility and opinion. The technical details are secondary, or more accurately, irrelevant, as in this case. So we move on to how we actually look at Trusteer Rapport. Well, in this talk, we intend to use a scientific approach. The reasons will become obvious soon. Well, we'll critically review previous attempts to take Trusteer Rapport apart. We'll take a guess as to the design, and then we'll evaluate and conclude. So, critical review. Well, first of all, the most interesting report was by an RLR UK. This is a Dr. Luke Heebs of the University of Kingston, if I'm not mistaken. On 19th of May 2009, Dr. Heebs made a blog post calling into question the veracity of the claims made by Trusteer in relation to Rapport. He then vowed to try and have a better look at the product to see if he could find out what the technologies were behind it. A few days later, another blog post was made confirming that RLR UK had had more of a look at Trusteer's report, and it seems that my fears were justified. Of course, no technical details were given, but the following conclusion was made, never backed up. You are teaching users only part of the story, and they will get lost in marketing hype and false claims. Of course, a silence then ensued for 265 days, after which on the 12th of February, another blog posting was made demonstrating that Trusteer Rapport was completely ineffective against a very well-known keylogger. The cause is as yet unknown, although a few days later he actually gave the cause. It was because he'd used RDP to log into the test host, and that's it. Curiously, little over a month later, RLR UK published a white paper. Now, some might read into this something other. You know, if you're conspiracy theorists, you might say, well, maybe it was paid off. Well, the white paper itself, the quote there, was commissioned by Trusteer. However, RLR UK were keen to stress that no commercial affiliation exists between the two companies, just that Trusteer paid for the white paper, probably. The white paper detailed, and this is actually a quote of the title, the testing of Rapport against specified keyloggers. This is the methodology that was used, which was actually described as being scientific. A variety of tools were used to test Rapport. The selection of tools was based on reports received of possible successful logging when running Rapport, and those specified by Trusteer. So if you actually take that sentence on its own and you deconstruct it into two parts, the second half is just self-explanatory. We did what Trusteer said. The first part is we did what Trusteer said, because if you actually think about it, where else are you going to get reports of possible successful logging when running Rapport, if not from Trusteer? So there you go. The end result was inevitable. This is actually a quote from the conclusions. Rapport was able to successfully defeat all the specified spyware in these tests, which is obvious. If you write a piece of software and you design it to subvert X, Y, and Z malware, if you then employ someone and pay them to do a test, to test against X, Y, and Z malware, then you either pass the test or you're a moron because you didn't actually implement it properly. So, there you go. RLR UK wished to stress how well Trusteer dealt with me. Presumably they paid the bill on time. And as I stated, RLR UK employs scientific methodologies when conducting any tests. That is, they check and recheck that they've done exactly what you said to do and nothing more. Information risk management fell for this one a while ago, a couple of years ago. This is actually something I always moan about when certifying Safe Central, because I took a look at Safe Central again, and that's basically what it amounts to. A rubber stamp. That's the extent of my abilities when it comes to GIMP. I'm not much of a graphics kind of guy. Other reports exist of equivalent hilarity. Well, one of them is by Matusek. That's their tagline, transparent security. Transparent because it probably isn't there. They actually got another quote. This is actually quite fun. Yeah, Matusek is a transparent security is a group of talented individuals with unique skills and know-how on the field of computer security. They list internet security, software design, which you didn't bother to look at, reverse engineering and malware prevention as their list of abilities. The Malware Research Group published another one entitled An Efficacy Report of a Trusteer Rapport. They actually used something that's particularly interesting in checking report. That is, they checked it against their own malware, but it's not actually malware. They give a description here. It's the MRG Financial Malware Simulator. This is a tool developed by Malware Research Group to properly simulate a zero-day piece of financial malware. The simulator is used to accurately model how real financial malware behaves on a system in the real world. So you have to ask the question, how do you simulate malware without writing malware? I don't think they'll answer that question. Anyway, so design hypothesis. Well, this is how anyone would envisage Trusteer Rapport to be designed. Well, we have a user browser. Actually, the size of the icons here doesn't imply precedence as opposed to the supporters page. So IE slightly smaller, not because I don't use IE or anything like that or any other conspiracy. And then you've got everyone else, every other program that exists on the box. And then someone at some point said, let there be a keyboard. And then, of course, the Russians turned up and everyone was infected with malware and all your keys were being robbed and this, that, and the other thing. And then Trusteer Rapport rode in on a big white horse and decided that they'd make it slightly different. By the way, the programs at the top, above the big black line, horizontal black line, that's userland, everything else kernel. So they said, right, well, we'll implement a driver. I'm just guessing at this point. And then we'll hook the keyboard. If the program that's taking the keyboard input happens to be anybody else, we won't bother. If it happens to be someone that's paid us a lot of money, then we'll encrypt it. And then we'll send the encrypted information to the browser. Well, there's a problem with this design, and that is, how does a browser get the decrypted keys? Well, it's obvious, you have to make that bidirectional. At some point, the browser must have some means to obtain the decrypted version of the encrypted keys. It simply stands to reason. Of course, if you read Trusteer's website, you'll never find any mention of this or how it works at all. Well, some questions still remain. Well, a mechanism must exist to turn encryption on and off. If it didn't, then basically Trusteer will be turning everybody's keyboard that installed Trusteer Rapport into an Enigma machine. With no way to turn it on or off, you'd have no way to type anything on a keyboard, you just get gibberish. And believe me, I've actually, in testing this, have encrypted my keyboard and had to physically reboot the machine several times. Well, you might ask, who provides such a capability to turn encryption on and off? That's a first valid question. Secondly, what encryption algorithm is in use? One thing you'll notice if you ever read any review of Trusteer Rapport is no one has ever mentioned anything about the encryption algorithm. Well, actually, that's not entirely true. There was one mention in RLR's UK's report, whereby they stated that if the user appears to enter the number 12341, then that will be encrypted with the 1 being the same letter. So basically he was hinting at a substitution cipher, but we'll come to that later. So what protocol is used by the browser to decrypt keys, since one must really exist? And if a protocol to decrypt keys does indeed exist, how do you lock this down to the browser? Well, experimental evaluation. Well, believe me when I say this, that literally this is actually from the OS X version. The only skill that is required to figure all this stuff out is quite literally a copy of IDA and minimal knowledge of x86. everything is provided for you. The names of the functions are so monumentally obvious that you couldn't possibly miss them. So communication, if you have any experience of OS X, sorry. Oh, I've been doing that stuff for too long now. Communication takes place via the get target and method for index method through the following data structure. That's actually the IO external methods data structure there. If you follow the value of EAX back, you see it's EDX, and EDX is compared against 1. So unless you want to return null, which is an error state, EDX must be 0 or 1. So we know there are 2 elements in that array, and indeed that is the case. We have the elements here. The first element here takes 1 scalar argument, no scalar outputs, no structure inputs, and no structure outputs, all 0. The name is Trusteer Rapport KE user client activate context method. Now activate is quite indicative of switching encryption on and off. The second one is even more blatant and obvious. That's just called decrypt key. Which, funnily enough, takes one scalar argument and 1 scalar output. I'll give you a good guess what the argument is and what the output is, but we'll come to that later. So first of all, we'll focus on the activate context method. The assembler is just simply too small, but it can be summarized as follows. We simply take an argument, scalar, number, 4 bytes, integer, check if it's greater than 0x7f with an unsigned check. If it isn't, we start the encryption. If it is, we stop it. How do we know that? Well, we have the implementation here, and it's too fuzzy to read, unfortunately. I can't actually zoom in because this is an old MacBook. God damn you, Apple. Anyway. But we simply have 1 argument here, we check it against a value, we call encryption start, encryption stop. I don't know if you can read the stop there, and the start over here, and then we just simply exit. So we'll look at encryption start. Well, how do you do that with this piece of code? It's rather self-explanatory. If anyone knows anything about IO kit on OS X, you simply open a service handle to a service match in the name, Trusteer Rapport KE. You open the service, at which time you can simply call IO connect call scalar method. The arguments are rather self-explanatory. The second one is the method index. So if you go back to the method array here, we're calling the 0th element, that's the first one, activate context method. We pass in our scalar value, which is input, which has got value 1. We tell it there are 1 input, and we specify null for the output scalars. So how do you disable encryption? Well, simple. You change input from 1 to -1. And I'll demo that now if it actually works. Okay, so there we have our NatWest there and our big green box. Usually the big green box of death because your computer's about to crash. Right. So we'll take a look, see if it's actually started. And we see that the kernel driver hasn't actually started yet. So first thing you do is scroll because the res is just too low. Click in the search box, which should, start the kernel driver. So it's now active, my keyboard is now hooked, thanks to NatWest. So we need a keylogger. Just so happens I'm a member of the Blue Peter generation, so I have one already made. You can ignore the rest of this, I'll just copy that. No, so there's nothing, nothing hidden up my sleeves. I'll give you a look at the source code. It's just a typical, simple OS X kernel, OS X userland keylogger. Compile it, which better compile. And we run it, and we see that it's actually failed. There's a reason for that. You need root. There we go. So with it being OS X, it's actually quite easy to change something to set UID root. So that should work now. Yay, and now we're waiting for keys. So we go back to our Safari, and in our search box we type something like report is cool. And we look back and we get A, B, C, D, E, F, G, H, I, D, D, J, which is the encrypted version. Okay. We leave our keylogger going, at which point we need to use our switch off. I'd better compile as well. There we go. And we run our switch off exploit, which simply sits there in a loop, switching off encryption. This better work. Right. And there you go, report is cool in clear text. There is a rather fundamental design flaw with Trusteer Rapport, and that is there is no way for a userland program to find out if encryption is actually on. So there is no way really to stop this. Well, obviously there's no way to stop it because anyone can call it, but that's beside the point anyway. So going back to the slides. How do I do that? Slideshow. Right, well, that's the question of the encryption algorithm, which is there. It's a rather wordy description of the encryption algorithm because some bright spark nagged me into writing a paper on this. And being a theoretical computer scientist, I like to draw these nice little fancy pictures. Those of you who really do not have a life will figure out that the set P at the top is actually corresponds perfectly to the alphabetic characters in alphabetical order for the Apple key codes. Apple, being what they are, didn't really like the ASCII standard and decided that they'd change it completely and make it look completely different. Anyway, the crux of the encryption algorithm is rather simple. It's a substitution cipher with the key, that is the substitution, being built dynamically from whatever the user happens to bang on the keyboard. So let's say your first character is B. Well, that will get assigned to the letter A. C, next character, will get B, and so on and so forth, all the way up to Z, at which point the mapping will be thrown out, which is here, and a new mapping will start to be constructed. As I said, RLR did hint that if you entered 1, 2, 3, 4, 1, then the two ones would be the same letter. And what they didn't figure out is what would happen if a user's password was actually A, B, C, D, E, F. Well, the encrypted version of that password is A, B, C, D, E, F. And yeah, so that's encryption. Okay. Well, encryption is defined as follows. That's a mathematical description of it for a block size n and a k-bit key. But if the key k is known to all parties and the function e collapses to the following, well, that's a simple obfuscation. So you can ask the question: is that encryption or is that obfuscation? I mean, I would err on the side and say it's actually encryption. Very, very weak encryption, incredibly stupid encryption, but still encryption. Internally, Trusteer developers are somewhat schizophrenic. Functions and strings often refer to deobfuscate, and then somewhere else they'll say encrypt. And even in one case, in one function, they flip twice, depending on the error. So obviously somebody came along later and decided that they better check for errors and put in a load of error messages. And so you end up with a big hodgepodge of deobfuscate password and decrypt key here and deobfuscate that here. There might be another reason for the confusion. I'll come to that later. And now we'll move on to the really stupid part, the decrypt key bit. In case this is the only reason why I went this far and didn't just stop at the switch off, is because the switch off actually, you need a loop. It's not pretty. You don't want your keylogger to use a lot of CPU power. You know, if you're a malware developer, you pride yourself on writing decent code. So you don't really want to get caught with a large amount of CPU time associated with your process. That is, well, unless you're smart enough to hide your process by some other means. So how do you decrypt a key? Well, this is a bit of a diagram to demonstrate that? Well, it comes in and it simply asks the question, is encryption enabled? Which just so happens to be a check on an object, ECX plus an offset of 204. If that is non-zero, it calls decrypt key, otherwise it doesn't. Okay. There's the disassembler of the decrypt key method. Pretty simple. All you do is just call a function decrypt key, which does all the checks and actually does the decryption if it's actually enabled. The second argument is the most interesting. That's actually your key that you pressed, the one you actually give as argument to the IO connect call scalar method. Here we have the pseudocode. This is literally all you need to decrypt a key. The only thing that's not given here is where key code comes from. Key code, I kept it as key code actually because the keylogger I actually used was shamelessly ripped off from a guy who wrote a book, Mac OS X Internals. So if you need source code for a keylogger and augment it to get around Rapport, then go ahead and just rip it off the same as I did. So you set input key to the key code you got from the keyboard. The decrypt key, obviously, I initialize it to 0, the decrypt size 1, and we just simply call the IO connect call scalar method again. Only this time we supply the output scalar and the output size. Well, I'll demo that. Okay. You can see the code here that does that exact thing, just there. And we'll see if that actually works. Of course, you need root again for that. Okay, and we're now waiting for keys from the keyboard. So back to our NatWest site, and we'll type something else. To stand is cool, he certainly is. Okay, and we go back to our keylogger and we see that we've got the decrypted version of the keys. On the left-hand side, next to the E, you see the, must have a bit of an error in there actually. So you've actually got the encrypted, we haven't got the encrypted version, you just got the decrypted on both sides, which is a little bit strange. I'll have to look into that. But still, test for yourselves and see if it works. Okay, so extending this to Windows, it turns out this isn't all that difficult. In effect, all they do is replace IO connect call scalar method with device IO control, which is pretty obvious. However, there's now a problem. It seems someone else figured this out. This was actually a video which was very quickly taken down. Ironically, it was actually put up by a Russian guy, called himself Epic Fail 666. Rapport stated that, Trusteer stated that they contacted the author of this video trying to get more information, but never actually managed to get any information. Nevertheless, they did do something. That is, they shielded the device IO control interface with encryption. Incredibly weird encryption, using a proprietary cipher and some form of compression. However, that's just obfuscation, because if you actually look at the code, you see a rather interesting export from the DLL in question called driver secret key. And you might ask yourself who was born on the 27th of February 1975 and the 7th of the 7th, 1977. Evidently not the CEO, because he's a little bit older than that from the photos anyway. But none of this really matters much anyway, for one simple principled reason. That is that obviously Trusteer code must use the encryption layer itself. Otherwise, how does it speak to its own driver? So where is that code? Well, it's in a DLL. So you want to decrypt a single key, well, that's no problem. You load the DLL and call the function to do it. So that's not all that difficult. All that effort kind of goes down the pan when you then implement the function, throw it in a DLL, and then forget what a DLL is. Note that if you actually want to look at rapport util.dll, it's the only part in Trusteer Rapport that is actually, well, obfuscated, and what some would say copy protected, or anti-debug protection, or whatever you call it. So you have to strip all that stuff away first, unless you actually want a copy, in which case I'll provide one. But now there's another problem, this time with the design. Trusteer decided that there are actually two ways to encrypt users' keys on Windows. One is via a kernel driver. The other is via calls to set window hook, with the ID hook being the global keyboard hook. The idea here is basically built on a simple assumption, a very inaccurate assumption of Trusteer, that if you call set window hook, you can guarantee that you will be the first function called when a user presses a key globally on the system, at which point you take the key, replace it, send a keyboard event via key KBD event or something like that. I forget what the function API is in Windows. And then you simply do not call next hook. Well, you might ask, is that correct? Well, actually, first of all, you might figure out that it's actually set in the configuration, which kind of begs the question that if the bank pays more, do they get better protection? However, the underlying premise is fundamentally incorrect. This is actually from Microsoft themselves. Because filter functions are not installed in any particular order, you cannot be sure where your function is in the filter function chain at any moment except at the moment of installation, when it is the first function in the chain. So basically, Trusteer are gambling that your keylogger, if you're a malware developer, calls set window hook once. If you happen to race Trusteer to get the first hook, then any protection they have is null and void. So verting this is actually rather trivial, and here's a screenshot to show it, although you might not be able to see it. We have NatWest, my favourite bank, on the right, and on the left here you have a keylogger in Windows, much the same as the OS X keylogger. The difference here is that you will see two sets of keys for every key pressed. You'll notice that the first key is actually the one that was typed. The second key is the encrypted equivalent. So we've effectively raced Trusteer to become the first handler. We are now the first handler and can read the keyboard perfectly. And then we're nice. You see, we're a nice piece of malware, so we actually pass the key. We call next hook so that Trusteer can do their thing. Yeah, it's always good to be nice. Okay, so conclusions. Thankfully, I'll stop boring you. Trusteer Rapport is completely ineffectual against even a slightly knowledgeable attacker, especially when it comes to keyloggers. Other parts of it that I won't go into here, like screen grabbing, well, on OS X it just doesn't exist, as I stated before. Well, in keeping with our scientific approach, we'll now reach a rather simple logical conclusion. We have two propositions. A, the skill required to subvert the keylogger protection of Trusteer Rapport is virtually zero, which is self-evident. B, Trusteer's rapturous chorus regarding the capabilities of Trusteer Rapport, it's the best thing, you know, it's genius, we're virtuous. Actually, that's actually a quote from a Gartner analyst who described Trusteer Rapport as, what was it? Yeah, virtuous. Quite how a company can be virtuous is beyond me, but still. So we asked the question, well, what if we combine the two propositions, A and B, what does it imply? Well, it obviously implies that Trusteer think malware developers are idiots. If I can do this in 10 minutes, then a malware developer certainly can. Well, now it's just a case of copy and paste. Or they could simply be maintaining a rhetorical stance, which is literally rule 1 of the Propagandist 101 handbook. Always, always, always stick to the same stance until somebody proves otherwise. Other problems exist in the design. Like I said, there is no means for a user-land program to determine if keylogger protection is actually active. So you don't even know if if some other malware is actually listening to the keys. And obviously, if you're in the kernel anyway, it couldn't possibly work for obvious reasons. Just one more thing before I end. This is something I'd actually like to copyright. It's an FA alert, which is known as a free advisory alert, which for the pen testers in the room is the thing you give to the boss 2 weeks before the pay review. Blue Gem Security, well, they claim that Trusteer are guilty of code theft. Their argument is that Trusteer reverse engineered their proprietary key encryption algorithm and copied it. Well, it's a bit ludicrous, really, when you consider it. If you actually look at Blue Gem's argument, internally it's self-contradictory for very simple reasons. Blue Gem allege that Trusteer are capable of reverse engineering their product and therefore are not stupid. But why would Trusteer, if they are not stupid, then implement an obviously terrible encryption algorithm which you've just reverse engineered? Surely you would replace it with something better. But nevertheless, Blue Gem still claim that they copied their proprietary encryption technology. So, questions. I asked one to Trusteer there, get instant answers. Unfortunately, there were no results to that one, which was kind of a surprise. Well, not actually. So, does anyone have any questions?
Any questions for me? What are the last 5 slides?
Sorry?
What are the last 5 slides?
So
you say that Trusteer are very clever because it seems that they've made a lot more money than writing keyloggers would to get.
Well, actually, I'd argue that writing keyloggers would make you a lot more money than what Trusteer has got, especially if, well, there's a...
Have you tried showing this to any of the banks and financial?
Yes, actually, yes. 3 of them. Only one ever replied, the others ignored it. Actually, I can't tell you the one that did reply because I'm under NDA from them, but the other 2 that didn't were Santander and RBS. They just didn't bother replying. But no, why would you? You know, there's a UK.sec on the riding the white horse. They'll obviously report any of this. If that does appear to actually be true, I would ask for one thing. If you are the poor unfortunate that gets to look at this and write the report, I would ask that you at least try and say, well, I got this from so-and-so before copying it. So, please, be nice.
Any other questions? Gentleman in the back there.
Is it a case that it's just a particularly bad idea poorly executed, or is it fundamental?
Oh, it's a fundamental flaw. I mean,
if you had addressed all the encryption issues and put the handles in.
okay. I've thought about this quite for a very, very long time, and there are several just monumental flaws with it. For instance, you have to provide a means to decrypt the keys. Simply have to. So how do you do that? How do you guarantee that it's you speaking to whoever provides the decrypted keys? How do you do that? Remember that the browser's running with the same privileges as a user. So even if you're a piece of malware and you have user privileges, how do you stop that? At some point there will be some magic key or some, like driver secret key or something like that you can just load a DLL and just pull straight out and, well, you can call their functions. I mean, that's just obvious. There will always be some, well, I reckon there would. I'd be very, 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 very surprised if anyone could implement something like this that would stand the test of time. That is more than an hour with someone with a disassembler and knows how to use a compiler. Any longer than an hour, I reckon, and you've got a good solution.
Gentleman in the back over there.
Yeah, you say that, and I buy everything you say. That's true. And you say, and most of the testing has been done by labs using existing malware recommended by Trusteer. But they were using existing malware that's out there, and it's not. Yes, you're quite correct. Subverting it seems fairly trivial, but that is not to say that those trivial steps have been done. by some of the existing tools out there, merely that it would be really easy for them to do it.
That's very, very true, yes. But even if you actually read Trusteer's marketing, one thing they do actually state is that the more common Trusteer becomes, the more greater a target it is. So they're actually using the fact that they have large numbers of customers forcing large numbers of users to use this. And they're using that as an excuse to say, well, our solution is obviously very good. Well, if you take the converse and think about it another way, they're using the fact that they reckon that they have a lot of users to prove that their software is good, therefore it will become a big target. So if there are so many people using it, it is obviously such a big target. There simply has to be somebody out there that's figured this out. I mean, there's already been one person. You're telling me that no other Russian has bothered?
UNRLR UK.
Yeah. Dr. Luke Heaves. Yeah. At least he
Now a
got
room
paid.
full of people.
Yeah, it's true. Well, I'll put the source code up on Digit Lab, so we'll see if Trusteer actually managed to patch it. I doubt they will.
Gentleman near the camera.
Do any of the banks intimate that if you're not running Trusteer, they might not refund your money if it gets nicked?
Now, it's strange you should say that, because if you actually read what users say, the good 90% of them are figuring that out. I mean, I don't know about the regulation in the UK, but, you know, it's been, well, for the banks to be in the position they're in, that is not on the street holding out a coffee cup asking for change because we bailed them out. If the banks manage to, I don't know about the regulation, as I said, because I do think that the banks are on the hook at the moment. If they succeed in getting rid of that, then a lot of people, if you read what people are actually saying about it, they're very scared. They're scared because, as one guy said, he installed it because he feared that exactly what you said. If somebody steals money from my account, and the bank's going to turn around and say, well, you didn't install this software, so I'm not going to cough up. As I said, I don't know about the regulation in the UK. It could be that the banks are legally forced to cough up. But if they ever succeed in getting rid of that, then you know, it's a 99% sure bet that they're one step away from saying that.
Has anyone argued it out in court in a civil case?
You'd have to look.
Surely the fact that you've actually got the court process running means that there's a target. That's the key structure you want anyway. Yeah. I mean, basically it's just saying, here lies where the money is.
Yeah, exactly, yeah. It's a simple 10-line patch. I mean, you can patch any keylogger now to ignore rapport completely.